Okay, let's do one more example. This will be fairly quick. I kind of introduced this at the end of that last note packet. It's an 8 by 24 again. We're going to use a D of 20. We've got a superimposed live load, no superimposed dead, but we're going to have to look up the self-weight. Main difference is it's a different strength of masonry. So I'm going to do this one the way I would realistically do it, and it's to use the design aids, and it'll be fairly short. Okay, so required steel. First thing we need to do is find the self-weight so that we have all of our loads for the demand side. So as you might recall, when we looked at that originally, it's in table GN3A. And I can go in and look that up for our specific case, and that self-weight part of, there's no additional dead load. Maybe I should just write it as self-weight. So our self-weight, if I look that up in the table, is 84 PSF. It's a 2-foot wide beam, or 2-foot tall beam, and I get 168 pounds per linear foot, and that's my whole dead load. Live loads is 1,400 pounds per linear foot. So my total load is 1,568 pounds per linear foot. Moment then, it's WL squared over 8. What was our span on this one? Span here was 14 feet. So WL squared over 8 is going to give me 38,416 pound-feet. Okay. Well, let's go ahead and figure out our KF value. So I'm looking for KF value so I can go into the tables. Our required moment, okay, so we have a required moment of 38,416 pound-feet. I better get that into inch feet because I'm going to go into the table and then divide by, I should say it's M over BD squared, right, is what I'm doing here. 7.625 times 20 squared. All right, so the KF value here is around 151, so it's actually 151.1. I would typically just leave it at 151 because I got to go into these tables anyway, but it doesn't hurt to have at least a decimal point extra precision here. So we'll go look at our tables, and the table that's going to work here, go to tables, and these are the tables in the ASD tables. This is going to be 26B. All right. So if I go in here, 25, those tables are with the 2000 that we've been doing. 26 starts to get me into the 2500 range. This one's clay, I don't want that. This one is clay, I don't want that. Here we go. Here's concrete. Oops. Concrete masonry. Got the right values for my masonry and steel. And so now I just need to go in and take a look. So I can either use this table and go in with my KF value. It's somewhere between these two, a little bit closer to this one. Right, so it's 151.1. So I can do, an interpolation between these two values, and I'll get a delta, or a row value between these two. Okay, or you can go in here, look at a K value of 151 or so, and come across here. Here's the first one, here's the second one. All right, so if you look at this, it's these guys. Second one, and I come down, and I end up right around here. A little harder to get a pure number up here. I'm somewhere in the order of 3/4 of the way between these two. Okay, JJ, stop. Sorry, dog, yelling at the dog in the headphones. So I can either try to pull that off the chart. If I go in and interpolate this, I get real close. I get 0.00527. Okay, so pick whatever you want to do and try to get reasonably close. And we get over here. This is going to give me a row. Well, on the tables, and I get a row of approximately 0.00527 required. So that's my required row. So it's the required steel area. And I know rho is A sub S over BD. So then I get a AS required of 0.80 inches squared. I can go into table GN-20, I believe, A. Okay, and I could look at that. Or I can also, kind of off the top of my head, I know that the number 6 bars are 0.44, but either way, I can look at two number 6s, and that gives me an area of steel of 0.88 inches squared, right? So that's greater than 0.8, and that gives me my answer for flexure. So this is the steel reinforcement required for this one. That's it. So it's pretty quick.